In these images, we see ice from enormous glaciers, ice sheets that are hundreds of thousands of years old, breaking up into chunks, and chunk by chunk by chunk, iceberg by iceberg, turning into global sea level rise. So having seen all of this in the course of a 30-year career, I was still a skeptic about climate change until about 10 years ago, because I thought the story of climate change was based on computer models. I hadn't realized it was based on concrete measurements of what the paleoclimates were, the ancient climates were, as recorded in the ice sheets, as recorded in deep ocean sediments, as recorded in lake sediments, tree rings, and a lot of other ways of measuring temperature. Earth is having a fever. In the past 100 years, the temperature of the Earth has gone up 1.3 degrees Fahrenheit, 0.75 degrees Celsius. And it's going to keep going up because we keep dumping fossil fuels into the atmosphere at the rate of about 2.5 parts per million per year. It's been a remorseless, steady increase. We have to turn that around. That's the crux. And someday I hope to emblazon that across Times Square in New York and a lot of other places. But anyway, off to the world of ice. We're up at the Columbia Glacier in Alaska. This is a view of what's called the calving face. This is what one of our cameras saw over the course of a few months. And you see the glacier flowing in from the right, dropping off into the sea, camera shooting every hour. If you look in the middle background, you can see the calving face bobbing up and down like a yo-yo. That means that glacier is floating and it's unstable, and you're about to see the consequences of that floating. To give you a little bit of a sense of scale, that calving face in this picture is about 325 feet tall. That's 32 stories. This is not a little cliff. This is like a major office building in an urban center. The calving face is the wall where the visible ice breaks off. But in fact, it goes down below sea level another couple thousand feet. So there's a wall of ice, a couple thousand feet deep, going down to bedrock if the glacier is grounded on bedrock, and floating if it isn't. Here's what Columbia has done. This is in south central Alaska. This was an aerial picture I did one day in June, 3 years ago. This is an aerial picture we did this year. That's the retreat of this glacier. The main stem, the main flow of the glacier is coming from the right, and it's going very rapidly up that stem. We're going to be up there in just a few more weeks, and we expect that it's probably retreated another half a mile, but if I got there and discovered that it had collapsed and it was 5 miles further back, I wouldn't be the least bit surprised. Now, it's really hard to grasp the scale of these places, because as the glaciers, one of the things is that places like Alaska and Greenland are huge. They're not normal landscapes. And as the glaciers are retreating, they're also deflating, like air is being let out of a balloon, right? And so there are features on this landscape. There's a ridge right in the middle of the picture up above where that arrow comes in that shows you that a little bit. There's a marker line called the trim line above our little red illustration there. This is something no self-respecting photographer would ever do. You put some cheesy illustration on your shot, right? And yet you have to do it sometimes to narrate these points. But in any case, the deflation of this glacier since 1984 has been higher than the Eiffel Tower, higher than the Empire State Building. A tremendous amount of ice has been let out of these valleys as it's retreated and deflated, gone back up valley. These changes in the alpine world are accelerating. It's not static. Particularly in the world of sea ice, the rate of natural change is outstripping predictions of just a few years ago, and the processes either are accelerating or the predictions were too low to begin with. But in any case, there are big, big changes happening as we speak. So here's another time-lapse shot of Columbia. And you see where it ended in these various spring days, June, May, then October. Now we turn on our time-lapse. This camera was shooting every hour. Geologic process in action here. And everybody says, well, don't they advance in the wintertime? No, it was retreating through the winter because it's an unhealthy glacier. Finally catches up to itself, it advances. And you can look at these pictures over and over again because there's such a strange, bizarre fascination in seeing these things you don't normally get to see come alive. I mean, we've been talking about seeing is believing and seeing the unseen at this TED Global. That's what you see with these cameras. The images make the invisible visible. Huge crevasses open up, these great ice islands break off. And now watch this. This has been the springtime this year. Huge collapse. That happened in about a month, the loss of all that ice. So that's where we started 3 years ago, way out on the left. That's where we were a few months ago, last time we were into Colombia. To give you a feeling for scale of the retreat, we did another cheesy illustration. London, there were British double-decker buses. If you line up 295 of those nose to tail, that's about how far back that was. It's a long way.